Alright, this is number 1 from homework 5. This is the question. For part A and B, you basically do them at the same time, because if you know the speed of the father, you can super easily find the speed of the son. So, we have 4 unknowns that relate to kinetic energy: the dad's mass and speed, and the son's mass and speed. But we only have 2 equations, so we need to somehow reduce them into 2 different variables. So first, we just write down the 2 equations we have, which is the father's kinetic energy times by 3, because the father is 1/3 of the son's kinetic energy, equals the son's kinetic energy, mass times velocity squared. I'm ignoring the 1/2 because there's a 1/2 on both sides, so it doesn't really matter. And then we know when the father increases his speed by 1, mass times velocity 1 plus 1 squared equals mass 2 times velocity 2 squared. Again, I'm ignoring the 1/2 because it's on both sides. So we need to find 2. So we need to make this into 2 different variables, as we have 2 equations. So we have to rewrite some of the variables. One very easy realization, but it's very important to make, is that we know that the father is 3 times heavier than the son. So we can just write the mass of the son as 1/3 as the mass of the father, or m2 equals 1/3 m1. So then we can plug that in these 2 equations. For every m2, just plug in 1/3 of m1. So this is just the same 2 equations up top, but just replaced. So let's simplify some of these equations. Let's start with the second one. So we have m1 times, this is still the same, times 1/3 m1 times velocity squared. We know these are equal. So first, I decided to multiply out the divide both sides by m1. I don't know why I put multiply, but it should be divide. And then we're stuck with this. And then remember from equation, and then let's look at equation 1. Here this used to be m2, but we just changed it to m1 divided by 3. That's what it says. So we could multiply both sides by 3 and then divide m1. So here we divide by 3 and then divide by m1. Why do we do this? Because we want to get rid of as many variables as possible. So now we just got rid of m1 and m2. Because in these 2 equations we have left, we have 2 variables, 2 equations. Now you can solve this in a variety of ways. I decided to use substitution. So for every time I see v2 squared in the first equation, I plug in 9v1 squared. A few other ways to do it. Then you do some algebra, and then you could solve this by using the quadratic formula. And then going through the quadratic formula, you will find this. Speed is asking for speed, so speed's always positive, so it's only this positive number. And remember, this what we're found here, at least in my work, I was finding v1. So now we know what v1 is. And the speed of the sun is just 3 times of that. And yeah. Oh, I did not explain why it's 3 times of that. Okay, well, you might have been able to figure it out, but the reason why it's 3 times is, okay. So the kinetic energy is 1/3. The father's kinetic energy is 1/3 of the sun, actually. So that's mv squared, but the father's 3 times heavier. So mv squared has to equal 1/3 in this case. So if the father's 3 times heavier, the v squared needs to be 9 times less. 9 times more, so the father can have 1/3 of the kinetic energy. So that means speed has to be 3 times higher, because 3 squared equals 9. But yeah.